Under 2.4, we are talking about quadratic graphs, and we are told that when fx is equals to ax squared plus bx plus c, the graph of y is equals to fx has a curved shape called a parabola. It has a shape called a parabola. Now, of course, the shape depends on the coefficient of x squared. We will see that later. You can sketch a quadratic graph by identifying key features. The coefficient of x squared, which is actually the value of a, determines the overall shape of the graph. And when a is greater than 0, or rather when a is positive value, then we have a shape of the parabola that way. And when a is less than 0, in short, when it is negative, then we have a shape of that nature. Now, we would want to highlight a few features of a quadratic graph, whatever the shape. And I just want to sketch here a very general parabola, and this one is y is equals to fx. And within this one, we are told that the graph crosses the y-axis when x is equals to 0. If this is the x-axis and this is the y-axis, when x is equals to 0, the graph crosses the y-axis. In fact, this line, the mathematical name of the y-axis is actually x is equals to 0. And of course, the coordinates at this particular point, call it point A, the coordinate is 0, c, the constant, which happens to be the c in the original quadratic equation. The graph crosses the x-axis when y is equals to 0. In fact, this line is also called y is equals to 0. And you can see that it crosses the x-axis along that point, or at that point, call it point B and point C. The x value of point, of course, we are going to talk about, this one is x1, 0, coordinates, and this is x2, 0, because y along the x-axis is always equals to 0. It is important to remember or even to note that the x coordinates are roots of the function fx. So this value of x, x1 and x2, they are roots of that particular function. So x1 and x2 are roots of the function fx. Some books will call them solutions. Some people will call them solutions, which is still quite all right. They are solutions, or they could be roots. Point number 3 to note. Is that quadratic graphs have one turning point, which can be either a minimum or a maximum. This one is called a minimum. You can see this turning point is a maximum. Depending on the shape of the graph, we have minimum or maximum. Since a parabola is symmetrical, the turning points and the line of symmetry, they are halfway between the roots. We are simply saying that if you have fx that way, this is y is equals to fx, it is symmetrical. That is the line of symmetry. If you can use the graph which we already have here, we are going to say that it is symmetrical. It has a line of symmetry. These have quite identical to the other half, and we are saying that the line of symmetry is halfway between the solutions, or the roots is actually halfway in between the roots. Having said that, there is a bold statement down there which you need to understand. You can find the coordinates. You can find the coordinates of the turning point of a quadratic graph by completing the square. And of course, if fx is given by a x plus p squared, already the square has been completed here. The graph of the graph y is equals to fx has a turning point, either maximum or minimum. It has to be, it is either way, it's a turning point at the point minus p, point coordinates minus p q. That is after the square has been completed. This piece of information is quite important. Just take care of it. If fx has this particular function after completing the square, then the same graph has the turning point whose coordinates are the value of p, but this time negative, and the value of q. This is the coordinates of the turning point. We shall see this in example 11, but for now, that is just an introduction of a general look of quadratic graphs. More will be seen in examples, but for now, that is simply what we may call an introduction of quadratic graphs. All right?